Thanks to the organizer for putting me right after Marco. Very convenient that he's just introduced the application area that is the focus of Vertex. I'm talking about a different piece of this, largely focused on Cabana. So the first half is going to be, if you're not familiar with Cabana and what we're doing there, I'll describe a bit of that, and then I'll transition to how are we using that in the Vertex project at a very, very high level, basically application agnostic, and where we're going in terms of interoperability with Trilinos. Here's the majority of my talk, software stacks and what we intend to support, or sorry, what we currently support and what we intend to support. So Cabana is a particle library layer on top of Kokkos. We certainly do not. First, we could not operate without Kokkos. We are fundamentally Kokkos-based. We are also intended to work alongside Kokkos, so we're not hiding that from a user. We do our best to make sure that everything from a user can pass through the Cabana layer into Kokkos, either through optional template arguments, or you can use the kind of simple interfaces aligned with the Kokkos defaults. So an example application would be Cabana MD, a very simple mesh-free molecular dynamics application. I've done a lot of work personally in discrete element method or paradynamics, a little bit in the more n-body cosmology world. But again, the mesh-free side is entirely Kokkos+MPI, where MPI is in fact optional, which is the intent of those dashed lines. We also have an interface to ArborX, another Kokkos-based library for geometric search there. And so right now that interface is built to create neighbor lists using the tree-based search from ArborX. Into the future, we'd like to use ArborX for more different pieces of physics. So say searching, like I'll talk about in the next part, searching for particles inside of other geometric elements. Also, quickly note that this is the core library, right? This is the intent of Cabana overall. But sorry, I've forgotten my exciting the colorful movie, right? So this is our fracture mechanics code that implements paradynamics in Cabana. But the transition here is meant to go to the grid subpackage, right? So this is fully structured grids, again, fully built on top of Kokkos or alongside Kokkos, right? So this is nominally to support the particle side of the library, but also you can write a full grid application if you'd like instead. So we had a student come in and write a phase field solver, which entirely used the grid subpackage and didn't touch particles whatsoever. But nominally what we do with this is to build particle and cell codes. Material point method is my flavor of pick in terms of more material science preferences. But again, this side builds both pieces together. And so we have fully rectilinear structured grids for, again, interpolating particles back and forth to that grid. And again, optional subcomponents, different library interfaces. Certainly, it's much easier and preferable in my as a developer to work with Kokkos-based optional dependencies. So things like ArborX. We have interfaces to Hyper and Hefty, which are not Kokkos-based, but with the continued development on the Kokkos FFT side, that's a very exciting thing that I'd like to interface towards from the CEA team. The Kokkos.com is another place that I'd like to heavily interact, where I think a good bit of the Cabana MPI routines would have a very good home in Kokkos.com instead. So Vertex Particles is the turn here for the first half of what is Cabana and what could it do, certainly today. Vertex Particles is a similarly fusion-based and a plasma physics-based application that uses Cabana right now almost entirely with structured grids for impurity tracking in fusion applications, right? So the particles in this context are ions such as tungsten, for example, flying around in your fusion reactor within a background approximation for your plasma. So we're statistically representing those particles and doing a pick-like algorithm to update those within a structured grid. Now, as a part of the Vertex project, what we found is that that's not sufficient. And so based on other work at Oak Ridge and other parts of the Vertex project that Marco talked to you about, we've started thinking a lot more about how do we interface with Trilinos. And so this is, I mentioned, or I should have explicitly mentioned, but I put on the slide at least Lance Bullerwell's name, who's doing the actual implementation of this. interoperability layer between Cabana, Arborex, and Trilinos, where I've just tried to simplify and say, well, that's where we're getting Kokkos and Panzer and many other sub-packages. But right now, I'll note that we do not directly interface with Vertex CFD, right? We're solving slightly different physics, solving for EM fields on that background grid, and making sure that, again, the ultimate piece here is that Cabana is doing all of our particle dynamics. Arborex is helping us search throughout that Trilinos grid to find which cell a given particle resides in. And then we've got some custom layers to do that linear interpolation inside of a reference element, where we're at least considering long-term to do higher order, certainly not right now. Into the long term, into the future work, of course, we'd like all these packages to interoperate together. We've got a third package that neither Marco and I have talked about yet, which is Vertex Maxwell solvers. And so, of course, the ultimate goal here is that we can build a layer that helps interoperate between Cabana, Arborex, Trilinos, et cetera, and to help users, at least in the fusion and plasma physics space, to build particles within your CFD code, potentially together with your Maxwell solvers as well, into these fully coupled, fully unstructured particle grid codes. So a couple of other quick notes in terms of what we're working on. The unstructured interoperability is a big focus right now for the rest of this year, certainly. Other projects have needed some optimizations and updates for neighbor list, so performance improvements for neighbor list generation, capabilities such as non-uniform search, where particles have vastly different physical sizes, has been an important update recently. More updates for 2D support. And some collaborators at UNM have been working with some advanced MPI interfaces and some new algorithmic approaches for particle communication. That's continuing. And then I'll go ahead and acknowledge our funding, and I'm happy to take any questions.